Hello students, I think you are well. On behalf of aptdemy, I, Professor Dr. Vidyut Gaurav, will discuss some problems on permutation, and total chapter is given in our e-learning platform. Those who have already registered, they have no problem, and those who have not yet registered, they will register within 31st July with some concessions. And here is a very good opportunity to contact with the respective professors online and offline classes. And also here is an announcement. So we have a free demonstration classes on 11th June Sunday from 9:30 to 5 in physics, chemistry and mathematics. So you can mail in our email address. So now we will start the two problems on permutation. Now first we discuss what is permutation. So permutation is nothing but an arrangement. What is the arrangement? The arrangement is this, that is, suppose we have two letters A and B. How can we arrange these two letters? In this way we can arrange, that is first A, then B, or first B, then A. These are the two arrangements, and this arrangement is called the permutation. So how many arrangements are there? In two ways we can arrange the two letters. Let's suppose we have three letters, say A, B, and C. How many arrangements? Taking all the letters, first you take A first, then B, C. Next A first, then C, B. Next, first you take B, then A, then C, B, C, A. Next C, A, B, and C, B, A. How many arrangements? So we can arrange the three letters in 6 ways. So two letters can be arranged in 2 ways. 3 letters can be arranged in 6 ways. Now we introduce a notation which is known as factorial notation. What is the factorial notation? We assume that factorial 0 is equal to 1. And what is our factorial 2? Factorial 2 means 1 into 2. The value of factorial 2 is our 2. What is our factorial 3? Factorial 3 is our 1 into 2 into 3. That is our 6. So factorial n, that is our 1 into 2 into 3 up to n. This is the factorial notation. Now if it happen that suppose we have 4 letters, say A, B, C, D. A, B, C, D, 4 letters. We have 4 letters A, B, C, D. Now we are taking all together. We are taking 3 out of 4. So 4 letters are there. I am taking 3 among them. So what is the notation? That is, we write here 4, P, 3. That is permutation of 4 things taking 3 at a time. If I take 2 at a time out of 4 letters, permutation of 4 things taking 2 at a time, the notation is 4p2. So in general, the permutation of n things taking r at a time, the formula for this is npr. This formula is factorial n by factorial n minus r. So this is the permutation of the arrangement of n things taking r at a time is our npr, that is our factorial n by factorial n minus r. So this is all about what we mean by arrangement of permutation. Now we start the first problem. The number of 6-letter words with or without meaning formed using all the letters of the word vowels so that the consonants never come together. We have to find out these arrangements. What is the letter? These are vowels. V, O, W, E, L, S. How many letters are there? 6 letters are there. Now, one thing is to be noted, if there is some repetitions, that is, suppose we have n things, of which p things of first kind, q things of second kind, and r things of third kind. We have n things, out of n things, p things of first kind, q things of second kind, and r things of third kind. So what is the number of arrangements? Number of arrangements will be, there is a repetitions, that is factorial n by factorial p into factorial q into factorial r. Now I will give you an example of this formula. Suppose we have a letter, say Calcutta, CALCUTTA. First, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters. First, you see that whether any repetition or not. Here we see that there are two C's, and two A's, and two C's, two A's, and two T's. Supply the formula. What is the number of arrangements? So the number of arrangements will be, equals to, how many number of letters are there? 8. So factorial 8 by factorial 2 into factorial 2 into factorial 2. So this is another formula where there is some repetition, that is, suppose you have n things of which p things of one kind, q things of second kind, r things of third kind. Number of arrangements will be factorial n by factorial p factorial q into factorial r. So I have taken the problem, the number of 6 letters with or without meaning formed using all the letters of the word vowels. So first we see that what is the number of letters? So number of letters equal to 6. There is no repetition. So number of arrangements will be factorial 6. So number of arrangements or number of permutations, number of arrangements equal to factorial 6. That means 6 into 5 into 4 into 3 into 2. So this is our 720. Now what is our problem? The consonants will never come together. First we say that how many consonants are there? How many consonants are there? V, this is the consonant, this is the W, this is the consonant, L is the consonant, S is the consonant. So 4 consonants are there and 2 vowels are there. That is, one is O and there is E. These are vowels and these are consonants. So if the four vowels or four consonants come together, what do you mean? Four consonants come together means taking the four consonants as one. We take the four consonants as one. And how many vowels are there? Two vowels are there. So what is the number of letters? If we take this is as one and here we have two vowels, so number of letters is out 3. Taking the consonants as one, as because the consonants will never come together. First we see that how many number of arrangements when the consonants will come together. When the consonants will come together, that is number of arrangements will be, here is our 1 and 2 values are there, so number of arrangements will be factorial 3, that is our 6. That is our 6. Again, the two vowels can be arranged among themselves. That is, we have how many vowels are there? Two vowels are there. So how many consonants are there? Consonants is our four consonants. Taking this as one and see that is our 6. So six are there. So if they are coming together, taking this as one. How many number of arrangements? So this is our factorial 3. That is our 6. Now one thing is that if this is 6. Now then again the four consonants. You have the four consonants. No repetition is there. They can be arranged. Four consonants can be arranged. Four consonants can be arranged among themselves in factorial 4. Factorial 4 ways. Factorial 4 means 24 ways. So the four consonants can be arranged in 24 ways. So number of arrangements in which the vowels, the consonants will come together, that will be 24 into 6. What is this? This is the number of arrangements. Number of arrangements in which consonants will come together. Consonants will come together. That is equal to 24 into 6. That is 144. What do you want? The consonants will never come together. Total number of arrangements is 720. When the consonants will come together, number of arrangements are 144. So number of arrangements when the consonants will not come together is 720 minus 144. This is our 576. 576. Again, we are discussing the problem. We have the word vowels. How many number of letters? Number of letters is the 6. Now there is no repetition, so the number of arrangements is factorial 6. That is the 720. Now we want when the consonants will not come together. First we find if the consonants come together, the number of arrangements. So taking the consonants as one, we have one and here two vowels, that is number of letters is 3. So they can be arranged in 6 ways. Again, the consonants can be arranged in factorial form, that is 24 ways. So the number of arrangements in which the consonants will come together is 24 into 6, that is 144. This is 144. So the number of arrangements where the consonants will never come together is totally the 720 minus 144, that is 576. I'll go to the next problem. Numbers are formed between 1000 and 3000 which are divisible by 4 using the digits 1, 2, 3, 4, 5 and 6 without repetition of digits. The total number of such numbers is, we have to find this. Number of numbers between 1000 and 3000. That means the numbers will be of how many digits? Numbers will be of 4-digit numbers. And which will be formed by the digits 1, 2, 3, 4, 5 and 6. Now, so as the numbers are between 1000 and 3000, the first digit, the digit in the thousand place, this will be 4-digit numbers. 4 4-digit numbers, 4-digit numbers. So digit in the thousand place, digit in the thousand place must be digit in the thousand place. Will be 1, 1 or 2. First of all, as the numbers are between 1000 and 3000, so the numbers will be of 3-digit, and first digit, that is digit in the thousand place, must be 1 or 2. And second, it is given that the number should be divisible by 4. A number will be divisible by 4. A number will be divisible by 4 if the last 2 digits, if the last 2 digits is divisible by 4. So first we start the thousand digit in thousand place as 1. Digit in the thousand place as 1. Now what was the last 2 digits? Digit in the thousand place, digit in the hundred place. Last 2 numbers, last 2 places. If the digit in the thousand place is 1, what will be the last 2 numbers which are divisible by 4? What I have written? A number will be divisible by 4 if the last 2 digits is divisible by 4. So how many digits are there? There, if you put 1 in the thousand place, so the remaining are 2, 3, 4, 5, 6. Now take the numbers which are 2 numbers which are divisible by 4. Say 24. So 24. Next, 36. Next, 56. Next, we will take 32. Next, you take 54. Sorry, 52. Next, 64. How many numbers are there? Last two digits should be taken in such a way that it is divisible by 4. I have taken 24, 36, all these up to 64. These numbers are all divisible by 4. So how many numbers are there? Here, these are 6 numbers. Number is 6. Here we have in the thousand place there is 1 digit. And how many digits are remaining? Here is 2, here is 3. So here is 3 digits are remaining. Why? We have 6 digits. 1, 2, 3, 4, 5, 6. Now the number should be divisible by 4. So the last 2 digits will be divisible by 4. These are 6 in number. So how many such numbers? Such numbers are such numbers are 1 into 3 into 6. That is our 18. Next case, this is our case 1. Why it is case 1? I have written a number divisible by 4. This is one thing, and digit in the thousand place will be 1 or 2. So first case we have taken digit in the thousand place is 1. Second case, when the digit in the thousand place, second case, when the digit in the thousand place is 2. How many numbers remaining? Again, you have to see that whether the last 2 digits divisible by 4 or not. If we put 2 here, how many remaining digits? 1, 3, 4, 5, 6. Write down the 2-digit numbers which are divisible by 4. So we can write, say, 1, 6, 16. We can write 56. Then we can write 56. Then we can write 64. So how many numbers are there? If the 2-digit numbers, these are 4 in number. 16, 36, 56 and 64. So 4 in numbers. Now here the remaining digit is 3. 1 remaining digit. Here is 1 digit is placed here, and remaining digit is here. 3 digits placed here in the 100 place. So such numbers are. So such numbers. What will be such numbers? So such numbers will be 1 into 3, 1 into 3 into 4. That is 12. We want the total number of numbers. So the total is 18 plus 12. That is our 30. Again, I am explaining this. Numbers are formed between 1000 and 3000. Whenever You are given that the numbers are between 1000 and 3000. The numbers must be of 4-digit numbers. This is one point. And next, the 1000 place, digit in the 1000 place must be 1 or 2. And here we use the digits 1, 2, 3, 4, 5, 6. And one point is there, the number should be divisible by 4. A number will be divisible by 4 when the last two digits will be divisible by 4. So if I put in 1000 place, 1 in the 1000 place, last two places will be filled up by 2, 3, 4, 5, 6. So the two-digit numbers are 6. So 6, you have the digit in the 100 place will come 3, number of digits will be 3, and here the 1. So the total number of such numbers is 18. And the second case similarly, taking 2 in the 1000 place, the total number of numbers are 12. So the total numbers 18 plus 12 equal to 30. Thank you.